Hello, everyone. Welcome. I hope you're having a great JNUC 2021. I'm Greg Mackey, a client engineer at Jamf. Today, I've got the privilege to introduce the Mac IBM team session reviewing advanced metrics, data collection, and reporting for Jamf Pro presented by Michelle Schaefer and Pat Norton. The Mac IBM team constantly seeks opportunities to improve the user experience on the Mac, and having information available to them to guide the path to improvement has no doubt helped their team make sure anyone who chooses a Mac at IBM do their best work on it. With visibility into data seeded from webhooks and tools they developed to integrate with Jamf Pro's APIs, the Mac at IBM team is able to make data-backed configuration management decisions that help them offer a great user experience. In this session, Pat and Michelle will walk through the Mac at IBM programs toolset and share ways other organizations in the community can build their own. Michelle will get us started, stepping through an introduction to webhooks features in Jamf Pro and sharing some resources and documentation available from Jamf that will help us kickstart gathering Jamf Pro event-driven data. Next, they'll share which webhooks are used within the Mac at IBM program today. Then, Pat will provide an in-depth tour of the components used within their toolset that processes data. He'll review the key metrics they focus on and share reporting insights that help the team gain visibility into their infrastructure. Finally, Pat will dig into the nuts and bolts that make up their webhook receiver tooling and share examples of code used to build it. We look forward to a time when it's right for us to gather together as a community in person again. But one of the great benefits of presenting at virtual JNUC this year is having the opportunity to engage with you during the session using the chat feature. Feel free to reach out with questions or feedback throughout. Without further ado, I'd like to introduce you to Michelle Schaefer.
Hi, my name is Michelle Schaefer, and I'm a platform engineer at IBM. In the next couple minutes, I'll go over some basics about webhooks and how to create one in Jamf Pro. Webhooks can provide a real-time response to events in the Jamf Pro Server. They allow you to subscribe to events, and when an event occurs, an HTTP post payload is sent to a specified URL. We want to show you something cool that is not in the admin's guide or in the documentation for the built-in Jamf Pro REST API. There are webhook features that are only accessible through the API. For the Smart Group Mobile Device Membership Change event, we can create a webhook to include any device attribute within the body of a webhook post. This means that any element that you can configure as a display field for an advanced search, including extension attributes, can be returned. This can be a great way to make your requests more efficient, removing the need for a callback to the API. Now, I'd like to show you a demo of this in action. To create a webhook in your Jamf Pro instance, navigate to Settings, Global Management, Webhooks, and click New. We'll set the display name as Jenny's Webhook. Next, provide a webhook URL. I obtained my URL from webhooks.site for testing purposes. Select an authentication type, connection timeout, read timeout, content type format, and the event that will trigger the webhook. You can learn more about each of these events at developer.jamf.com. The table of contents has a list of each event. Notice that for the Smart Group Mobile Device Membership Change event, there is the ability to return additional inventory fields. Here is the documentation with a sample request to return the IP address and the last enrollment display fields. Let's see it in action now and create a webhook using the API. The display field I specifically want to see returned is the user phone number. The post was a success, and we can refresh the page to see our new webhook in the GUI. Now we can select a specific target smart group to receive the webhook event. In this case, where the model is an iPhone XR. Now, in order to receive the webhook, there has to be a change. The mobile device has to be added to the group or removed from the group. In order to simulate this, we have made the value for the model of the smart group iPhone XS, so we'll correct it to XR. Now we see that Jenny's webhook has returned the result with the additional phone number display field of 867-5309. I'd like to emphasize that webhooks.site that is used for this demo is a public webhook testing venue. Please do not send production webhooks here. So we just explored some really cool functionality that explores device details. Here at IBM, we use webhooks in a different way. To hear a little bit more about what we're up to, here's Patrick Norton.
Hello, folks. My name is Pat Norton. I am a senior platform engineer here at IBM. I'm going to take you through a quick tour of the webhooks that Mac at IBM uses. We currently are using 4 of the webhooks that Jamf Pro provides for our metrics and reporting. The first being the computer check-in. That's the interval that you have set in your Jamf Pro for how often computers check in. It's broken down into 6 components, which are client check-in, every hour, network state change, startup, login, and log out. We also use the computer added, which fires at an enrollment, computer inventory completed, which executes during recon, and computer policy finished, which is executed every time an end user computer completes a policy. Mac at IBM uses an extensive list of components to track and process webhooks. Obviously, this includes the Jamf Pro Server, or we wouldn't be presenting this topic at JNUC, but it's worth mentioning that this is where all of our webhooks originate. The next component is our PHP webhook receivers. These are PHP files that receive the webhook event and write a file or a log file. We will provide examples of these files at the end of the presentation. Moving on, we use Zabbix, which is an open source infrastructure monitoring tool with an agent that runs on each of our servers. Other options for infrastructure monitoring tools with a similar capacity could be New Relic, Datadog, Dynatrace, Nagios, and many others. For those of you that may remember our 2016 session on metrics, at that point we were using Nagios, but we've since transitioned to Zabbix because Zabbix provides native plugins for Grafana, as well as an updated interface and more familiarity with that product from our team. This agent that runs on each server can collect lots of different data points such as CPU performance, hard drive space, as well as execute custom scripts. We use the custom script capabilities of it to process webhooks and create a time series of how many of each type of webhook are executed on a per minute interval. The next component that we'll cover is Elastic Cloud Enterprise, which is a private on-premises version of Elastic Cloud. Elasticsearch is an enterprise NoSQL database for storing and aggregating log messages, as well as other custom data. We use it for Jamf Pro logs, server logs, as well as collecting an entry for every policy each computer executes from Jamf Pro. Elasticsearch does provide an open source version that is available free for use. And it's quite easy to set up on your local Mac. The next part of our process focuses on the Python processing scripts. We use several different Python scripts to process computer inventory webhooks and make an API call back to the Jamf Pro Server. These scripts collect and process a subset of computer information, including custom extension attributes that we then store in a MySQL database. This allows us to have a single table of denormalized information that other teams at IBM may access for reporting, security, and other internal processes without needing to execute complex queries against the Jamf Pro database directly. Finally, the last component is Grafana. Grafana is an open source display tool. It supports many different data sources, MySQL, Zabbix, Prometheus, Elasticsearch, and many others. This allows us to build complex dashboards that draw data in from multiple sources and display them together on the proverbial single pane of glass. To recap the workflow, Jamf Pro sends a webhook to a PHP receiver, and then it's processed using custom Python scripts for the middleware update, Zabbix counts, or Elasticsearch logging, depending on the webhook that we're processing. So what kind of metrics do we gather from all of these webhooks? The primary one is Jamf Pro performance. The number of events that occur on a per-minute interval, such as check-ins, policies, inventories, and enrollments, allow us to track how active Jamf Pro is along with what our users are doing. As I stated earlier, we split the check-in webhook into its component parts of check-in every hour, network state change, startup, login, and log out. These splits are very useful for us for making decisions, such as the best time to roll out updates, patches, and then monitor their progress, along with how those decisions affect overall infrastructure performance. An interesting fun fact here is that Mac IBM processes about 1.5 million webhooks per 24-hour period. As I stated earlier, we collect all the types of those webhooks and process them into the Zabbix database on a per-minute interval. This allows us to see exactly what sort of processes the Jamf Pro Server is up to at any given time, both real-time and historically. Being able to reference previous versions of Jamf Pro versus new versions of Jamf Pro has been very useful for us, as well as identify specific issues with policies or deployments, particularly configuration profiles, that are not performing properly after release. Grafana makes displaying these items very easy because it allows for graphing multiple webhooks on a single panel and allows enabling or disabling a subset of those items graphed to correlate any relationships that may present themselves. By simply clicking the name of the webhook at the bottom of the graph, you can select one or multiple, and it will change the graph based on those items. Using trend graphs, we are able to make data-driven decisions. Here is a 24-hour trend, which makes it very easy to visualize when our users are active based on webhook activity. We are also able to compare certain metrics, such as how many policies run as a result of computers checking in, or the type of check-ins that are running. We're also able to evaluate really large spans of time, such as 30 days, for activity trends. Grafana also enables us to compare certain metrics from the webhook operations from other system performance metrics such as database operations and system load. This helps us to understand capacity planning and how to correctly size our infrastructure to handle the load our user operations place on it. You may be wondering, what have we done with this data? Well, this data is useful for sharing with other organizations at IBM as well as our vendors. It has resulted in us disabling the network state change trigger, which used to be required in Jamf Pro. Data from this type of webhook processing was useful for us because we were able to see that disabling that trigger would reduce the load, particularly for check-ins, on the Jamf Pro server by almost half. We also have quite a bit of Zabbix monitoring built around webhooks, which alerts us to further breakdowns in infrastructure that may not be quite as easily visible based solely on server performance metrics, such as CPU or RAM. Let's go a little bit more in depth here on some of the information that I covered earlier. How does Zabbix count webhooks? When the Jamf Pro sends a webhook, it points to that PHP receiver script. The PHP receiver script writes files into specific folders based on the webhook. On a 1-minute interval, Zabbix executes a custom Python script that looks in that folder, counts the number of files that are present, representing the webhooks. The Python script reports the count back to Zabbix, which stores the data point of the number of the webhooks that were sent for each type during that minute and stores the metric. It then deletes those files. It does this by moving the files into a working directory before counting so that it doesn't interrupt the PHP script from continuing to accumulate files while it is counting. Moving on to some policy execution data, let's take a closer look at how we process webhooks for the policies run from Jamf Pro. I do apologize for redacting some of the data on these screenshots, but it was necessary to protect the private information of our clients. These screenshots should still be useful without that information. We log every policy executed in our environments and send that data to Elasticsearch so that we can use it to perform a very detailed analysis on the policies that have been running. Using this data, we have built 3 types of Grafana boards to display policies. This board in particular represents all of the policies that have run. We break them down into 2 main categories: automated policies versus user policies. Automated policies are run on a check-in type trigger versus user policies are the ones that are executed from self-service. We then display information such as the success and failure rates for those policy types, as well as display the most active users and policies. Continuing on the policy dashboard, we display the most active users, what type of policy they're executing, such as update, reinstall, uninstall, as well as showing a table of the policy frequency execution, such as daily, weekly, or once per computer. Grafana also allows for dynamic linking, so these graphs are clickable and will take the viewer to the dashboards that we will show next. This one is a single policy execution. Here we're looking at a Grafana board for a specific policy, one single policy. It shows success, failure, and a time series trend, as well as the users who have executed that policy most often. This is very useful data to track large deployments of software, identify failures, failure rate, and users who may be stuck in a form of processing loop, causing that policy to execute a very high number of occurrences. Here we're looking at the third Grafana board for a single user. At our scale, it is often difficult to use the policy history in Jamf Pro. This board allows us to see all of the policies that a single user has executed and items such as pass, fail, and some information about that computer from our reporting middleware system, allowing us to further correlate that system with information we know about it. Storing the policy data in Elasticsearch is one of the more complicated webhook processes that we perform. When we set this up, we determined that we wanted to inject more information to Elasticsearch than the webhooks provided. The option that Michelle showed for adding additional webhooks information did not exist at the time that we built this. So rather than make 400,000 API calls back to the Jamf Pro Server every day, we created a process that stores policy information locally on the server that's processing the webhooks. Every 30 minutes, a Python script runs that makes a single API call back to the Jamf Pro API and stores policy information for us in XML files. When a webhook is received, the PHP file accesses the locally stored policy information and adds additional key pairs to the JSON that it writes to the logs that are then fed to Elasticsearch using the FileBeat log monitor. Elasticsearch is a JSON-based NoSQL database, so it natively understands JSON. By writing these augmented webhooks to a login, By writing the augmented webhooks to a log, in JSON, FileBeat easily ingests that information into Elasticsearch for us to display with Grafana. The final webhook process that we use here at Mac IBM keeps our middleware reporting system in sync with Jamf Pro. We use this system to allow other teams to access that subset of Jamf Pro data through the single table denormalized MySQL database. Many other teams use this data for security, reporting, and compliance. We store several key pieces of data here, such as hardware, information, user, and custom extension attributes. When a computer submits inventory data, the webhook is sent to the PHP receiver. That receiver writes a file as in our other processes. The Python script runs on a 5-minute cron that makes an API call back to the Jamf Pro API, processes the information that we need to store, and injects or updates the record in the MySQL database. The script that we've written for that is fairly involved, but the process would not be too difficult for someone with good Python skills. The process works similar to this. Gather all the JSS IDs from the XML files, loop through them, and make an API call for each JSS ID to the computer's API endpoint. organize that data in the correct format, and create or update records in the MySQL database. Why do we do this? Separation of data for access controls and increased efficiency, as well as creating and storing data specific to IBM or other organizations. We felt that it would be very useful to provide some code examples to the community for receiving webhook data in a few different formats that we use at Mac IBM. These code examples are, of course, provided without warranty and should be thoroughly tested before being used in any production environments. They are very similar to versions that we have written, but they've been edited rather heavily, so there is a good possibility that I may have made a mistake. You have been suitably warned. Before running these in production, please test them. This PHP script will write a single file in a single location from a webhook it receives. This is similar to the receiver that we would use for counting webhook events with Zabbix for policies, inventories, or enrollments. The top of the file includes a very important function that uses the JPS header authentication method to protect the server from accepting webhooks from anyone that might try to send them without that authorization. This method is used for all of our webhook receivers, but will not be shown in the scripts on the slides to save some space, but will be included in the Resource Center handouts. For some webhooks, we need to perform multiple operations on each webhook, such as count the number of inventories that have taken place, as well as update our middleware system. Rather than send 2 webhooks from the Jamf Pro Server, which is an option, we have the PHP file write the same file to 2 locations. We see both of the fopen statements with the path to directory there, where it's going to take the file that it receives and write it to 2 separate locations. Another useful operation that we perform is to split the webhook for check-in, as we discussed earlier, into the types of check-ins before we count them, writing them into separate folders. This allows us obviously better insight into why our clients are checking in. Was it a check-in on interval, startup, or maybe a logout? This script is truncated. I've only included 2 of the methods here on the slide, the if-val statements. The full version will be included in the handouts. And finally, the last code example that we will provide is the option to log webhook data to a file. This is a very useful operation for us because we're using Elasticsearch's FileBeat monitor to read that data and send it to Elasticsearch. In our case, we also add the additional JSON items that's not included in the script here to the array before writing it. Thank you, folks. That concludes my portion of the Webhooks presentation.
Oh, thanks, Pat and Michelle. Michelle, I still have that song stuck in my head. 8675309. Pat, it's awesome. Everyone, check out the session resources section for reference to examples, documentation that can help us all utilize the technologies Mac IBM uses that give admins visibility to device management metrics and extend our ability to help people have a great experience with their Apple devices. We look forward to catching up with you all in the chat. Enjoy the rest of JNUC 2021. Thanks for joining, everyone.
Thanks, folks.